Exercise 2.7. The following graph represents velocity timed graph. Identify what kind of motion a particle undergoes in each graph. Okay. Now we have to interpret these graphs. Okay. Now you take the first graph. Here this is x-axis, it's time, and y-axis it is velocity. Now here you can see the body starts from rest from the origin and it is moving with what? Constant velocity. That is, as the time increases, the velocity is also increasing. So this is a linear graph. This is a what? Linear graph. So what can you say about the acceleration? We can say the acceleration is a constant. The acceleration is a what? Constant, because the body is moving with a constant velocity. Okay, so we can say the acceleration is constant. So you can write this in this graph. Acceleration A is what? Constant. Okay, now in the second graph, here also it is velocity time graph. Now the body is moving with a uniform velocity. The body is moving with what? Uniform velocity. So when the body is moving with uniform velocity, so what you can write? The acceleration is 0. So what will happen to the velocity? Velocity is what? Constant. So what will happen to the acceleration? Acceleration is equal to what? 0. Coming to the third graph. Here the velocity increases with increases of time. Okay. But it is not from the origin. It is not from the origin. After some times only it is moving with a constant acceleration, that is uniform acceleration. But the acceleration is what? Greater than that of the first graph. So what you can say here, acceleration is constant but greater than first graph. Now coming to this diagram. Here this is not a constant. The velocity what? Changes. Okay. As the time changes, the velocity is also what? Changing. So it represents what? Increasing acceleration. So what you can say? Acceleration is variable. Here it is not a constant. Here the acceleration is what? Variable.